Is the screen is visible to all?
Yes, sir.
Okay. So we are going to start the subject operating system here, and as far as the part of the concern and operating system, if you are going for, then definitely we need to know that what particular basic topics are there in your subject operating system, that is MCS-41. And here here if you look into the particular subject, then we can possibly find different topics which supposed to be cover starting from the introductions. So normally what we cover here, if you look into, then I can possibly say that we definitely go for a discussion at this particular place, that what kind of particular operating systems are there, what exactly operating system is there. So if you are looking into, then I can possibly say I have the first module in operating system, that take you to a tour of different types of operating system, what exactly operating system, how does it works, and so on. So so first module normally we go for a introduction part, or we can say that introduction to your operating system, or we can say OS. So this consists of what are the different types, or we can say what different types of operating system we have, how does they work, what is their operational style, and so on, and what may be the basic difference in between. So this could be the part of your discussion, then to have what exactly the operating system works for. So here different possible tasks are there, and those possible tasks, whatever we are discussing, they may be depending on this different type of operating systems. Now if you come for next, what is there in the second module, we can possibly say in the second module, just depending on the type of operating system we discuss, that means how does the entire system is going to work for different type of operating system. So normally if you go for telling about the operating system, they must be discussed under two different platforms. Once that the part of your logical operational operating systems, so that's called as the part of your logical operational system. Other one is the part of your hardwares, that is physical, or we can say operating system manages the hardware, the second particular requirement what we discussed under operating system. Now if you go for the part of your internals of this particular requirement, then what we can say, we have to go for the part of your discussions like uh, in the logical part, we have to go for the discussions like process, or we can say process management. So this normally have the point of discussion that's supposed to called as the process management. And if this process management is there, then definitely the process management need to discuss about process concepts, process concepts, and then we can have CPU CPU scheduling. Then we have process synchronization. Then we can possibly go for the part of your deadlocks. So four different subjects are there under this logical discussion of operating system. We will know what is a process, we will know what are different CPU scheduling algorithms, we will know that if one process is executing at the same time, if other process wants to execute, then what is going to happen. That's make a synchronization discussion. And finally comes to the deadlock where no process can able to execute. So this is what the point of discussion in case of process management. So this is the second bit, just after the introduction. Then if you go for the part of your further discussion, so further discussion in operating system, just after the process management, we say that we have to go for different possible discussions with respect to the part of your requirement. With respect to the particular requirement means to say, there are different types of possibilities to go for the next module. The next module is related to the hardware. So here we have to discuss about memory management. So in case of memory management, we have different topics to discuss, supposed to like main memory. So what is your main memory? If you can tell, is it your RAM? So main memory normally discussed about RAM that we have at this particular point of time, and we can go for the part of your main memory discussion there. And in this case, if you are going for the part of your execution, and those particular executions will go for main memory, and they can go for execution on virtual memory. They can possibly go for the part of your part we can say uh, file systems. So this is the logical representation of storage device. So we can have the part of your different requirements, which can possibly talk you about memory managements, where main memory is, where virtual memory is, where file system is. So this is regarding the part of your different subjects we can go for in the memory management. Now coming to the next part, where we will go for the further discussions. So further discussion supposed to be like here, and we can say just after the part of your memory management, we can say the further discussion maybe your step number 4. And this will say that we have to go for the next it's supposed to find out the part of your we can say protection and security. So This supposed to be find out different kind of protection features in file system, in security features to the file system. So different possible file access. So file implementation, file file implementation, then we can able to go for the part of your mm, file allocations, so allocation methods, allocation method, allocation method, and we can finally go for the security measures with respect to the protection, that's called as the matrix, access matrix. The access matrix, possibly help you to find out different possible protections. So this is all about what normally we can go for in different possible phases, and at this particular point of time, and this particularly have different flavors. We can say that this particularly have different types of flavors to discuss, where we can go for the part of your discussion, and here that particular discussion will definitely take you to the complete learning of operating system. So here we can go for different part of your operating systems, like ZY format, like your part of your other formats, like CUI formats. But nowadays, if you look into that, the GUI format is working a lot. CUI format normally we are not working. But here, if you go for the CUI GUI format, that debate is already over. But people are now thinking of whether they can able to go for open platform or not, or we can say go open free platform or not. So normally people are migrating to the part of your what, the part of your Ubuntu platform in comparison to the part of your here what we could say, and according to the part of your Windows platform. So we can possibly have this two possible things, where we can say that what kind of possibilities are there, whether we can able to go for executions or not. But we believe that people will like much the Ubuntu, because of this protection and security will be much more in comparison to Windows platform. Now coming to the part of your discussion with respect to a book. So if you go for the book, there are many operating system books you can find throughout, but we can say the operating system book that comes with Galvin, written by Galvin, Concepts of Operating System, written by Galvin. That book is the best book for undergraduate or postgraduate, any place. If you go for the operating system subject, so depending on the requirement, that particular book is most good book, and much friendly book to the students. So you can go for that book also, so that can help you. Along with your materials are there, IGNO materials are there, you can take help from that also. So this is all about the introduction, that before you start, you should know what are the different subjects there, and what are the different possible topics there. Now, to start with, so what we have to start with. Now normally, if you remember, for we are going to start with that a part of your execution platform, and then we will go for the execution. So let us start the introduction module that we need to discuss for. So at this particular point, I can possibly say I would like to go for the part of your introduction module to start. So now you can see here, we are again at this particular part of your discussion to know that what kind of particular introduction discuss we have to do. Now, if you believe what exactly operating system, many books write different kind of definitions, and these all different kind of definitions normally says what what exactly the dictionary meaning of a operating system. But if you really wants to understand what exactly a operating system works for at this particular point of time, I would say there may be many reasons why this operating system came to picture, and we can think of that whether we can go for the executions or not. So there are many reasons. I had listed only few here that I want to make my utilization high. So definitely here, whenever if you are thinking about your executions, whenever you are thinking about the part of your high utilization rate, we definitely go for the part of your utilization rates to know. And this utilization rates are not other than the part of your CPU utilization rate. So we are believing that we definitely demands high utilization rate on my CPU. Now if you go for the part of your other specifications, other specific task where we definitely work on. So at that particular point, we can say the professionability in the operating of the system. Now, if you think back, the Hubbard one machine in 1940s, that particular machine, it's supposed to a machine which has to be kept in a room. So it must be with a 20 by 20 room where we can able to accommodate this machine, how big this machine is. And this machine is supposed to consist of, let's take 3000 number of switches, electrical switches, which we have to switch on and switch off for the operation of the computer system. And what this computer system can do, this can go for a execution with respect to some of particular operations, like plus, minus, and up to multiplication, not even the division. And it can go for the part of your algebraic equations, the roots to find a quadratic equation up to a degree of 2. So we can go for the roots to find a square plus b square plus 2ab. So up to that, I can able to find out the roots. So we can able to do this simple things. And you just believe that we have how many number of switches, and what are the different particular majors, what are the different particular part of your challenges they met the different challenges. Possibly we can say that they have to go for the switches to control, and they have to remember. Main challenge is that they have to remember the switches. And these switches, if they have to remember, we all know, as a human being, to remember the operation of 3000 number of switches is not possible at all. So here comes the invention of commands. Then in commands also, whenever we work, that we think of that whenever we work with the commands, I have to remember those commands even. So at this particular point, I can possibly say, if you are going for the commands also, that commands will take care of everything. But at this particular point, we have to know what command you have to use. The same problem again comes. I have to remember command. What is the problem with the CUI? The problem with the CUI definitely says that I have to remember the command. Up to what extent you can remember? You can remember one command, 100 commands, and then we can go for 200 commands and 500 commands. After that, I don't think so. So that makes a situation demand. Now coming to the third one, the setup time. If you think of, in this Hubbard one machine, if you are going to set up everything, I have to minimum switches to on. Minimum switches we have to on to work out with this machine is supposed to be that 140 number of switches which we have to on, so that machine will get ready to start execution. So you think of that finding 140 number of switches out of 3000, and that we have to let the system to start is not that much easy, and the time it could take to start the machine is much more. So at this particular point of level, we can say that we really not working in a healthy environment where the system would work better or system would do better. Then coming to the part of your mode of interactions. At any point of time, if you are trying to interact, every time whenever a process or program is going to be executed, we need the interaction as a user. And the user, if not able to interact, then definitely we cannot able to go for the executions. So why we cannot? Because if anything wrong, if anything goes wrong, then I cannot able to make the corrections. So interaction must be there to make some corrections. Otherwise, it is very difficult to work on that. Then coming to next, we can possibly go for the part of your the high demand feature that's supposed to called as automatic job sequencing. Switch on one button. Just think of on your laptop. You have to switch on only one button, and you have to wait. Your laptop will start automatically take you to the desktop page. We don't have to use much more number of a particular part of your buttons too. Even if during my btech time, whenever I did at that particular point of time, we have machines with one power button, one restart button, but still now we do not have restart button even. So you have only one single button. So one single power button, I can able to adjust, I can able to do everything that my system wants to work with, that my system wants to operate with. So many things has to be happen and in our life, and many changes we need in our system. So that makes a point that why people need a operating system who can able to do job on behalf of them, and we can proceed further. So this is what I have to go further in execution, and we have to go for the part of your further part of your operating systems to discuss. So this history behind us, which will help us to understand that what really we want to do and what really we could go for. Now coming to the part of your uh, definitions. Coming to the definitions, if you go for, then this particular definition will definitely help you in many way of regards, where I can say a collection of system program that entrusted with effective utilization of the computer. So here many different definitions are there if you go through the book, but I tried to write my definition where I can understand my visibility. The visibility behind a operating system, if you are thinking for, then we can possibly say that I have to understand the complete logic behind it. The logic behind it, let us take something like this. Okay, if you are visiting a let's take if you are visiting to the pizza corner. So let's take you went to Pizza Hut, and you want to order some pizza on your choice. So at that particular point of time, you are not going to the kitchen directly. You are not directly entering into the kitchen of the Pizza Hut. You have to be a area where you are accessible. You are there only, and no other one is allowed. Or we can say we have a space where we can able to make use of the system. Beyond that, we cannot make use of. We must know what are our restrictions. So in a system, up to what extent we can make use of, and after that who will use, how these things will be operated, that we have to understand. So we can possibly go for the material, your study material to read, and where one simple statement is written that this operating system act as an interface in between the part of your user and the computer hardware. What does this interface word means for? Interface means to have many definitions, many clarifications, so that we can understand what exactly we are working with. So you went to the Pizza Hut, you search for the menu, you search for the menu, and there you choose something That means one particular category of a particular pizza that you like, and then you instruct, you add, these are the toppings on my choice, and then you prefer for the extra cheese or something, what the all things you go on choosing one after another as a user. And then the particular person is there who attends you from the respective pizza hut. They're supposed to carry this particular order to the person available in the kitchen. So this person plays a vital role to execute your task. And he or she has to do, his job is that he has to take your request to the kitchen, and there is a cook available. The cook will read your request, then confirm, yes, this can be done. Then the order will be get confirmed. You will get to know your pizza will be with you within next 20 minutes. So this confirmation get backs to you, and you are waiting for 20 minutes on your table, that whether your pizza will come. So here comes the system works with that. The cook is at one level, you are at one level, and this person who comes to you, he is managing your version to the cook, and the cook's version to you. That means it's a kind of interface. It's a kind of interface who takes care your journey or your requirement to the cook, and cook will deliver you the job. And at this point of time, whenever you see to the kitchen, before the kitchen it is written, no one is allowed, or any outsider is not allowed. So that means here they had created a protection that everybody cannot enter into this. In your system also that has been created. What? In a particular part where user is working, and in another part the operating system works. So that's supposed to be the part of your division we normally do. And that's called as the part of your user mode, that particularly called as part of your user mode, where the user is working. And if a user wants to go for the operating system, they have to go for the kernel, or we can say system mode. So every system will go in between this user mode to kernel mode to user mode, so that they can able to complete the execution at a stretch. And if you look into the structure of this, we supposed to look like this. There are different components. You can see user will be at one level. User will be at one level at here, and I am drawing this line. Why? Because a user is not capable to go beyond this. User is not capable to go beyond this, because a user is using compiler. क्या करते हो? TCC, GCC, and Turbo C compiler, MCC compiler. These different compilers you are using. Assembler 2.5. So assemblers you are using. Text editors, GI editor, VI editor, many editors you are using. You are using database, MySQL, and so on, DB2, something kind of that takes care of your data. So you are working with this. They are they are supposed to be the applications, or and this supposed to be the application where user can interact. So they are supposed to be the user applications. And we supposed to say these applications will let the user to know that what they really want. And these applications also let the operating system to know that how you want to execute this. So the application programs, whatever working, their job is that to represent your mind of job or mind of the work in such a way that the system can understand. Or we can say it will translate your job into a machine readable format, where the operating system can understand this. So this understandability will go further to take a hardware in operation, and they can able to go for it. So but still one more layer is there, that we would like to say that here the operating system does the interface in between the user in one end, in other end, to the computer hardwares. But at this level, if you really wants to understand what is there in the further stages, yes, I would like to say that operating systems are not directly connected to the hardwares. They are not directly connected to the hardware. Then who are there? They are supposed to be the device controllers. So you can see here, we are going to work with hardwares, that means devices. So we have to go for that any particular part of your necessity you are working with, that definitely know what exactly the part of your working with the necessity of your demand. So we have different kind of device controllers that's supposed to called as the part of your what drivers, or sometimes we call them as we sometimes call them as the part of your different drivers for different kind of devices. So at any point of time, if you are going for, then they supposed to be in different modes to find out, and those different particular modes will help you to find different kind of device drivers. So I can go for the part of your different control of device, and those different control of device is connected to the part of your drivers and so on, to find out the executions. So this is what I have in case of the computer system, and further they are connected to whom? Further they are connected to the part of your computer hardwares. And this connectivity line will say, at one level here, we are working with whom? We are working with the part of your user mode. In the other part, we have part of your kernel mode. And the process is, or a program or your task is going to execute in between the part of your user mode to kernel mode to user mode, and so on. So this is what I can possibly go for the execution one after another. So that's why if somebody asks for that, how exactly, how in a better manner we can possibly go for the executions one after another, we can understand. So this is what we can possibly say, that a process is going to execute in between user mode to kernel mode. So we can analyze this with respect to the analogy we discuss. The analogy says, I visited the pizza hut, and here there is a dining place in the pizza hut, that is your user mode, where you are accessible, and the kernel mode is the kitchen where the cook is as available, and you cannot directly go to there. You are not allowed. So you have to take the help of the operating system, so that operating system can go to you, take your request and give it to the cook, and then only we can able to say, yes, we can able to get my pizza after 20 minutes. So this is what normally we have to understand what exactly operating system is, and how does they work in between the part of your user to the hardware to the device controller, then the device drivers. Anybody need to ask any question based on this?
No, sir.
Okay. So and,
No, sir.
so based on this particular part of your computer requirement, we can conclude that the definition with respect to the part of your operating system objectives, where we can understand that the system whatever we are working, that must be having a proper configuration. We know every operating system comes with their configurations, and the configuration supports the operating systems to work. For example, your RAM site should be this. You must have minimum memory space like this. So this is what normally we say, that system configuration. So depending on the user requirement, also you can go for Ubuntu, you can go for the other environments also, depending on the requirement policy. So requirement policy, I can say, if you go for Ubuntu 14.4 and lesser versions, they will not work on a touchscreen laptop. If you go beyond that, they will work on a touchscreen laptop. So features are added every time. Features are added at any point of situation. Then coming for the part of your my end of definition, which I believe that what exactly a operating system objective is. The operating system objective is to create the infrastructure, where a user can work, and where this infrastructure is going to be added. This must be added to the bare hardware, so that the hardware start giving the service to the infrastructure, and the infrastructure can give the service to the part of your software. And where the software is present, software is directly or indirectly, if you look into, software is directly or indirectly going for the part of your user connectivity. So that's why this particular part of your definition, we can believe that I can able to go for managing the situation, and we can understand better from the point of view of your understanding. So question can ask sometimes, justify the statement, software infrastructure added on bare hardware. Operating system is what? Operating system is a software. We can possibly say what exactly the software you mean for. The mean for the software is supposed to say it is a collection of system software. I already told in the first beginning, I can say collection of system programs. We know what is application program, we know what is a system program. These are all system programs. I told that we have to further connect it to the device drivers, we have to further connect it to the part of your other possible requirements. So device controller and device drivers are not other than the system collections or system program collections. And those particular system program collections definitely help you to identify whether the software operating system can work for the user, so that their hardware services can reach to the user. So this is what the part of your operating system objectives. Then what kind of particular resource systems we are going to make use of? In many books, if you read, operating system is called as many different names. Sometimes operating system called as resource allocator, sometimes operating system called as control program. So sometimes when a operating system called as resource allocator, we understand that a particular process that wants to execute definitely demands some part of your execution. And that means to say here, if I would like to go for A equal to B plus C, minimum I will require what is the value of A, what is the value of B, what is the value of C, and here we have to know what is the data type of the result. Minimum these informations I have to go for. And to store this 5 integer type, I need a space. To store this integer type 6, I need a space. So from where I will get, where to store them? So these resources must be there. So these resources must be there so that efficiently I can able to execute my program. This is one kind of resource. Other thing is that a CPU must be allocated. I must need a CPU so that we can able to execute this. That is also a resource. So resource can be of two types: hardware resource, software resource. So if you go for the CPU, that's a hardware. If you go for 5 and 6, they are the values. They are supposed to be called as software resources. These resources can also work perfectly at this particular point, and we can possibly work much better, much in a situation to handle all kind of challenges, and we can do the task. So here, and the operating system also called as resource allocator. So other than a resource allocator, if you think, it also keep track of which resource is busy and which resource is free. So depending on the accountability of the resource availability, the process could go for its execution or it's not. So depending on the resource allocator scheme also, we have to think of that whether we can able to keep track of which resource is free, which resource is busy, and how much easy it is for a operating system. That's a debate. None comes for the part of your control program. Yes, we are writing control program. I less than equal to 0. Then what to do? So you are writing if statement, you are writing while, you are writing do while, you are writing many conditional statements. And on those conditions, you had given a condition that the program has to follow. And if you are writing a particular program where we have to follow different conditions, believe that if you are not following those, then the user is not going to satisfy with the result. So every control of execution must be followed by the operating system. Otherwise, we will not able to get the proper results. So this is what we need to go for at the point of time. If you are working with the operating systems, it can called as a resource allocator. It can called as a control program. Now I can able to say it can also be called as a government. So I can add this. I can add this. Why this should be work as a government? I can say it giving the resources before execution. During the execution, it controls the program and gives it back to the correct result. Then what not it is doing? It is doing everything. So why not I call the operating system to be a governing body inside the system who governs everything so that execution can go in a right order so that and we can able to get the satisfaction at the end result at the end result as a user. So this is what we can say how operating system act. Operating system defines themselves from the point of view of a operating system. So this is possibly we can say at any point of time we are going for. So this possibly the part of your different uh, uh, act of operating system. Now if you go for the part of your uh, types. Now next is that we have to know that what exactly different types we have. That means to say how many different type of operating system we have. So we have different type of operating systems, but believing every type of operating system, whatever we are working with, they are supposed to be a part of your operating system depending on the user's choice. So user's choice basically have different to different depending on their requirement, but we have to understand all operating system as per the need and facts. So let us come to the part of your classification. You can see many names, but before going for these many names, I would like to take you to a broad classification. So a operating system, if you are thinking, then there are different types. We so different types of operating systems with respect to the broad classification, I can say. So keeping the user in mind, I have a broad classification supposed to call as non-interactive voice. We can also go for interactive voice. So non-interactive OS means here operating system does not allow the user to interact with the program during the execution. Program whenever executes, whenever you are trying to execute your program, the operating system does not allow the user to interact. That means no modification is allowed. If you can know even you did a wrong, that also you are not allowed to make changes. So at this particular point of time, we can possibly say this may be a very sensitive drawback, but we have this category in the internal in the situations. So now further, I can possibly go for interactive operating system. That means in situation where we could go for the executions, and we can also interact, we can make some modifications and so on. So in this perspective, if you are looking into, then I could say that this particular batch operating system, and we can add one more, that is we can say serial processing. Serial processing means one by one execution of processes. So serial processing normally we have before to batch operating system. So these two things, a batch operating system and serial processing, if you are looking into, they definitely comes under non-interactive operating systems. So others, whatever left, so these all whatever left, they are going for the part of your interactive operating systems. So batch operating system, serial processing system, they are non-interactive. So they do not allow the user to interact during the execution, but others and very good with interactive operating systems, they allow yeah, to interact with the program during the execution. Now, what may be the obvious drawback, or the obvious drawback if I follow for my types of operating systems, then I could say the different types of operating system, whatever we go for, that could be at any point of time to start. But if you are going for the execution, if you are moving for the part of your execution, then definitely we can find out different possible tasks to work. These tasks are what? First task is that we can go for the non-interactive ways to work without any interaction. We can go for interactive ways to act with different for the discussions. Now coming to the part of first type in non-interactive. So I can go for the part of your non-interactive operating systems here. So non-interactive operating system starts with the part of your serial processing. So serial processing. So serial processing is normally works with different task of executions. The different task of execution can further finds the execution one after another. So executing task, executing your task one by one without any interaction. So this could go for one by one syntax of execution at one particular point of time. Then come for the batch, the part of your batch operating system. So the real intelligence comes here in batch operating system. Why? Because main theme behind the batch operating system to reduce setup time. There are many reasons I had told in the beginning, in the history, that what we really have, and that could go for the reason behind the creation of operating systems. So reduce the setup time is the theme behind the operating system. Why I say? Because if I have programs, if I have a set of program, let's take I have a set of program, or we can say user. We have user program, and this program consists of addition, subtraction, division, reminders, and so on, many more. So here we can look into that. Additions, we have 50 additions, we have 20 subtractions, we have 30 reminders to calculate. So modulus operation, I have 30, 50 and 20. So what do you think? If I go for executing this in a serial manner, one after another, every time I have to give the resource. I have to go for allocation of resource. Every time you will go for allocation of resource. But batch operating system does what? Batch operating system only checks you are 50, you have 50 number of additions. Okay. So I will prepare this 50 with a batch. With a batch. And what is the theme behind? The theme behind is similarity of job. So similar kind of job, or we can say same types of job, or similar kind of same type job or task. So this can possibly go for the part of your execution here. So I can possibly find many different tasks, many different possible ways to go for creating batches. So you have a MCA batch, there are many subjects. So you can possibly go for one batch, one subject, one subject, one batch. So according to the subject, the batch may change, but here batch is same, but subject will change. So for time slots, we had given operating system this time slot, database this time slot, and so on. So during that time slot, you are going to work with. So this is what the part of your batch says. So jobs with similar kind of need, job with similar kind of need or same type of job can be together, can be together, and those particular programs can run at a time. But remember, at this particular point of time, please remember that whenever we go for the executions, whenever we go for the part of your batch execution, whenever a execution starts, remember you are not executing the task. Remember what I am trying to say. You are not executing the particular task. You are executing what? CPU is going to execute. CPU is going to execute batch, as I am taking the class for a batch. So in the batch, what is available? 50 number of additions. Addition. So during the execution, for 50 number of additions, the allocation will be done once. If the allocation will be done once, we can save the time very nicely. We can save the time for 49 times. We allocate once for 50 programs, you will do the allocation 50 times. Now you will do once. That means 49 times the time it will take to allocate the resource. Completely saved. So here we are making the system faster, that the setup time is much faster, setting up the processes will be much faster. So that's why this will be a serious significance change in the execution times. And during the execution, if the user wants to interact during the particular time of requirement, if the user wants to interact, say no. So no user interaction, as it is a non-interactive. So no user interaction during execution. So if you are going for this, we can save much time. We remember, but to think of using no interaction, if anything goes wrong, and if that makes any particular wrong result creation, or due to non-interactive pattern, there is a uh, wrong in the result, that may affect the end product. So that's why batch operating system is there, and very nicely reducing the setup time, but it fails when it comes for the part of your further next discussion are supposed to be the part of your interaction. So any error, any end product result having error or any bugs are there dynamically on runtime, I cannot make any changes. So I can look into the bug only after the 50 additions are over, and at that point of time, everything goes over. If you go for correcting it, then you have to execute again 50 number of programs, because you are not dealing with the program, you are dealing with the batch. So this may be a tedious job, or again time taking job, which again increases the time and demands to execute the batch with respect to the reduction of setup time. So that's why the batch operating system, some way good and some way bad experience also. We are having bad experience also. So we have to look into the next modification into your operating systems. Any questions? Anybody need to ask? Okay. So based on the part of your demands and further requirements, here we can possibly say that interaction is one of the demanded feature during the design of the operating system. So that's why what we have to do, I have to go for the next operating systems to find next operating system supposed to be like your multi-programming operating system. So multi-programming is not a very big name or big rocket science, because multi-programming it's supposed to deal with multiple number of programs at the same time. But the challenge for the CPU is that how it can be possible with multiple number of programs to execute at a time. So what do they do? The cpu is available here, and interaction is allowed, so we can have multiple number of programs to execute. So we have, let's take p1 to execute, p2 to execute, p3 to execute, p4, p5 to execute. And here, if cpu executing p1 right now, and what are the rules and regulations fixed to it? The rules and regulation fixed to it is that until and unless p1 not completed, so that we can say uh, till p1 termi till p1 terminate, cpu will be with cpu will be with p1. So this rule is slightly inflexible, we can say. If p1 process is there, and if it would have some cpu computation, that means it would need to go for cpu computation, then CPU will be busy. If it go for the input output, then CPU will be not working there. So at that particular point of time, we can possibly say that here comes the point of discussion. How could I able to manage the situation? So managing of situation will say, I would rather say some correction in my rule. The correction has been done to the word terminate. Why it is called as a going waiting for the termination? Once the particular process goes for IO, let's take P1 wants to go for IO execution, input output execution. At that particular point of time, CPU will not busy. So CPU will switch over to what? CPU must be switch over to the next process. This is how they will go or switch from one to other and find out the execution. But in this discussion, there are two different challenges. So what are the two different challenges here? First challenge is that when you think about the CPU is not executing during the IO, first question is that who will execute then? Who will execute the IO of the P1? Because we know definitely CPU is with P2. P2 is executing now with the CPU. Then who executes the IO of P1? This is the first question we have to answer. Then second possibility of question is that possibility of the question is that if you could say that P1 goes to IO, you tell me the time. You tell me the time when P1 will go for the IO. If P1 will continue indefinitely with the CPU execution is going on with the P1. It is not ending. Then P1 will never enter into the IO execution. If P1 will not enter into the IO execution, then P2 cannot come for the execution. It will go to the termination. This termination will take 1 day, 2 day, 3 day, 4 day. I do not know. So the visibility or the circumstances says I cannot guarantee in this process of system when does P2 come for execution. Hope you understand what exactly I am trying to say. And here in this point, we could go for the situation to look into that. At this particular point of time, we can go for the positions, and we can deal with all other possibilities where we could work with. And this could be the point of the requirement at this particular place, and we can have our discussion going on. So answering to this two particular part of the question, we can possibly say first thing is that for the IO we have to go for the DMA. So first thing is that if you are working, if you want to go for parallelly working, then we have to introduce direct memory access, DMA. IO means it's just to work in between the IO and the memory. So direct memory access will deal with that at this particular point. And if you are going for the part of your execution in that sequence, then definitely I could say I had a CPU execution, I have a DMA execution, and CPU and DMA execution can possibly done at any point of time, at any point of situation here to go for. So at this particular situation, if you have, I can go for telling you further executions of different operating system in the next class tomorrow. So I will stop my discussion here. Uh, yes. Anybody need to ask any question?
No, sir.
Okay. So thank you all.
Okay. Thank you, sir. I will see the subject. If I have any doubt, I'll ask tomorrow, sir.
Yes, you can ask.
Okay. Thank you, sir.
Thank
Thank you, sir.
thank you.
मोहन सर।
हाँ जी।
हाँ सर, कैसे हैं सर?
हाँ सर, ठीक हो। आपने रोल नंबर टाइप नहीं किया, अटेंडेंस नहीं किया शायद ना, आगे आगे दे दिए थे आप?
पहले दे दिया सर, दोबारा से देना है क्या?
अच्छा, नहीं सर, ठीक है।
नहीं।
ओके, थैंक यू।
ओके।